Hello, how's it going? I just got in. Jeez, I'm so cold. Okay, sorry if there's a bit of a rumble going on outside. I'm not sure what's causing that, but I just wanted to go over some of the talks that I saw. I tried to take notes. Thank you to all presenters, of course. And if I didn't get detailed notes, maybe I was just too tired. I tried to take something away from everything. So I've just wrapped up day two. We started off with Chris Glover from Google giving a talk on Vulkan for All, and what he really, the real thrust of that was Vulkan for all platforms, all users, all hardware, all everything. And the major takeaway is that people are saying, hey, Vulkan's too big, it's a lot to learn. But the major approach should be focusing on the third-party tools which sit between Vulkan and the end user, the programmer, in the sense that Vulkan is like an API for writing APIs. So some examples of sort of very commonly used tools are the Vulkan HPP, Vulkan Memory Allocator, SpearV Reflect, just to check with the SpearV code and all that sort of stuff. And yeah, possibly making Vulkan more low level, so exposing things like image layouts and tiling options and things like that, which I thought was very interesting. The first part of the day was mostly LunaG and mostly focused around validation. So we had a presentation from Jeremy Gebbin from LunaG talking about using Vulkan validation effectively. And I learned that VUID from the validation layer stands for Valid Usage ID, which I didn't know. It's just very nice to know. Talking about different sorts of validation layers which can be enabled. So for instance, you have your core validation layers, but you might also want to specifically check your thread safety or your object lifetime, and enabling all of those in one go will be really bad for performance. So what you want to do is sort of enable them one at a time. And the easiest way to do that is through the Vulkan configurator. It has other options as well, so you can limit, if you're throwing a validation error every frame, you can limit the number of those messages which get printed out. And I got the feeling that the major priority of LunaG at the moment is with covering all of the valid usage IDs, all of the use cases. At the moment, they have 79% is their highest rate of completion in the core functionality. Mesh shaders are probably their lowest rate of completion at 23%, but that totally makes sense because mesh shaders have just come in recently. Ray tracing, because I'm interested in that, is 73% covered. So yeah, the major priority is any sort of incomplete issue which is raised. I'll get onto that. Following that, we looked at enhanced debugging with the Vulkan loader. This talk was given by Mark Young at LunaG, and the Vulkan loader is really a sort of command line tool. So after your Vulkan program has been built and everything, it might be built in a test state, and then a different end user might run it, a different developer might run it, and it'll throw an error or something, just because some validation layers need to be disabled or for whatever reason. So if you need to either enable or disable validation layers for a program that's pre-built, this is a command line tool which can do that. And then Christophe Riccier from LunaG finished off that morning session with a more in-depth tutorial on using the Vulkan configurator to set up validation layers. Then we had a break, and then we heard from Greg Fisher at LunaG. He was talking about using RenderDoc with Vulkan and baking in debug info to shaders. So in the past, you would get your SpearV shader, you load it up, you run it, and if you want to debug it with RenderDoc, the best you can do is sort of look at a disassembly. However, now both of the major compilers, GLSL-Lang and DXC, have options to bake in debug symbols, basically, to the shader, which are ignored at runtime, but they're used by RenderDoc. So you can capture a frame in RenderDoc and then step through the code line by line, set breakpoints, go forwards, go backwards. Now, one issue that was raised here is that it is emulating the GPU. So if you were using a compute shader or something with shared memory, it would not have those more complex second order effects of having multiple threads working in the same memory space. It just wouldn't account for that. But for basic syntax and debugging and things, it is a good option. We then heard from Brad Grantham at LunaG talking about GFX Reconstruct, which will essentially record all of the function calls and commands which a program executes with their inputs and outputs and bounce them down to a JSON file. Now, it was noted that this is very similar to RenderDoc, but the use case for this is if you want to automate your tests, because whereas RenderDoc is a GUI application, GFX Reconstruct is a command line application. It exports to JSON, it runs from the command line, so you could have a farm of different systems running the program and just test down a bunch of different cases. Then we had a break, and then the next part here was, whoops, I'm on the wrong day. There we are. The next part here was informally sort of Vulkan for numerical methods, if you will. Vulkan for science with Vulkan. So we heard from Bernhard Kerbel from INRIA talking about transitioning to Vulkan for compute. Now, this is a very, very interesting lecture. I didn't write a lot of notes here, but I did find it very interesting. Running Vulkan for compute, the setup is significantly simpler than Vulkan for graphics. You don't have to climb the mountain of drawing that triangle. You know what I mean. So he actually is planning and doing the first stages of implementing a course on Vulkan for compute. For beginners, he takes students with no low-level graphics programming experience and runs from the basics of just printing stuff out to the screen, from a compute shader to copying memory, synchronizing operations and things, all in Vulkan Compute, and then building up to a final open-ended project, like make something cool, like a point cloud renderer or a ray tracer or something. And yeah, I really appreciated that talk. I thought it was, I find teaching very cool. So one of the big things I took away from this is we were saying that teaching synchronization is difficult, and the question is, can we gamify it? And I think from a teaching perspective, if we can take any topic which is difficult, which is the common sticking point, and try to gamify it, I think that's a great way to turn things around. Remember the Marauder? Remember the Marauder from Doom Eternal? I haven't played Doom Eternal. Well, I did actually. There's another story there. I won't get into it. But the big thing around the Marauder from Doom Eternal is it's meant to be notoriously difficult. And some people are saying, well, once you learn the game, once you learn the rules of the game, the most difficult thing becomes fun. I mean, I know what this is like. You know the difficulty I've had with stairs in Paris. But once I learnt how to do it, the most difficult thing became fun. Stairs are fun. Memory synchronization can be fun. Descriptor sets can be fun. Then we had a talk on VKFFT by Dmitry Tolmachov, talking about his experience implementing a fast Fourier transform single header library in Vulkan and comparing that to the performance of CUDA. So then we had virtual reality-based visualization of large scientific data. This is by Mark Bo Jensen from the Technical University of Denmark. A very interesting talk. Specifically, so the task was essentially we want to make a VR data visualizer, specifically a high polygon model visualizer. How do we do that? So originally he tried to write it in Unity and found that the performance just wasn't there, just wasn't working. Then he switched things over to the Unity Universal Render Pipeline. Performance improved significantly, but then just for fun, he learnt Vulkan and made a Vulkan-based program for that using mesh shaders. So mesh shaders are the sort of the modern replacement for tessellation shaders and geometry shaders in general, and he had incredible performance gains working in mesh shaders. And one of the big takeaways from this is, yeah, if you were programming an environment from scratch, you'd probably want to start with a pre-built environment like Unity or Unreal, Unreal Nanite technology or something, just so you're not reinventing the wheel. However, for this specific task, the task was just to view a single high polygon model in VR. And so that was a use case where having a specific implementation could actually be higher performance, because you don't need to worry about dynamic state and all sorts of things. And then we had a panel discussion. So the major topics that were discussed there were GSL and HLSL, whether Vulkan should choose one or make a different language or something, or sort of what the philosophy was behind that. And it was mentioned that most Vulkan users are using GLSL, although HLSL is considered, I guess, to be the more expressive language. However, DXC, DirectX compiler development is slow. It was mentioned that in some cases it's taking them a year to merge specific pull requests, and it was mentioned that LunaG's resources are pretty stretched at the moment. They're primarily, well, not stretched, but you know what I mean. It's mostly going into getting those validation layers up to snuff, covering all the VUIDs and stuff. So they're not really in a position where they can speed up the HLSL compiler development. And then another major topic was whether Vulkan should stick with its initial philosophy, which was the phrasing was to lock down things that cost. So like pipeline creation and stuff, should we have that dynamic or should we lock that down? So from Vulkan 1.0, they were very strict about locking down state, validating everything up front and not changing things around too much. And then in subsequent versions, they have relaxed that a little bit, and there's a bit of discussion on what do people want. Do we want it to be more dynamic or do we want it to be more fixed? Hey, let me know down below. Personally, I want it to be more fixed. I like that environment. I'm orthodox in that way. That was it. So that's just been my little overcap of day 2. There's been a lot to take in. I mean, I was sort of zonked. I'm sort of zonked now. I'm sort of tired. But yeah, it's really cool. Very exciting. It definitely motivates me seeing a lot of people who are into this sort of stuff. It's not just me in my basement anymore. It involves a lot of very cool people. And it has also motivated me to re-examine my Vulkan series. I know what you're thinking. How many Vulkan series do we need? So what I'm going to do is, currently with the Vulkan series, I'm going to get things up to maybe object models, loading those, and then I'll say, okay, cap that for now. And I will just give a sort of overview where I'm going. So for the month of February, I'm going to keep on the cycle of just grinding out as much Rust, Web GPU, and Metal content as I can. Get that done. It's probably a good idea. Then from maybe March onwards, I'm planning a weekly OpenGL C++ course, because I know that I've sort of neglected my OpenGL C++. Some of those videos are a little bit rushed. I can probably do a better job there. It'll be about a 12 or 13 weekly thing. But then after that, I'm going to make the best darn Vulkan course that I can. And similarly, I'll aim to do that on a weekly basis. I'll be using more of these tools. Of course, Vulkan HPP, I'm already using that, but Vulkan Memory Allocator, SpearV Reflect. Chris said regarding VMA, he said, if you're not using Vulkan Memory Allocator, you're not using Vulkan properly. Leave that up to interpretation, but I will use that tool because I think it's a good tool. And using RenderDoc as well, along with Vulkan, to sort of get more detailed feedback, rather than building the Vulkan environment from the ground up, like I did in this series, which I'm still going to keep current. This will be a separate series that I'll make. In this new series that I plan to develop, I will actually start from a completed Vulkan program and work backwards a little bit. We'll see how that goes. I'm still planning out what that's going to look like, but I'm inspired. I'm very keen to make the best darn Vulkan series I can and teach the best I can. And it's just so cool. I'm having so much fun. Once I finish recording this, I'll probably pop down the road, grab some sparkling mineral water, and then we've got the conference dinner after that. So yeah, thanks for watching. All the best. And thank you to my patrons as well. Support, it's €2. 2 euros. I spent too much time in Europe. $2.50 a month. That's it. You get video credit. I really appreciate it. You're helping keep the channel alive. I mean, hey, I would do this forever anyway, regardless, but I do want to make this my full-time thing. So thank you, and I'll come at you tomorrow with more updates. Actually, tomorrow, I'll give a little preview. Tomorrow is going to be really cool. We're going to have a look at mesh shading and all these things, Vulkan video. Got some ray tracing stuff and Vulkan VK, which I'm very excited for. Anyway, that's it from me. Thank you. All the best. Bye.